Mae, si yo quiero agregar notas aquí, ese mae de Google me deja agregar notas o no, Caragua.
No, no, no deja.
Qué ratas. Y es que yo lo pudiera hacer con Edge, pero es que el más está bloqueado, como tiene horas de copyright. Entonces no se puede, digamos, como agregar notas, no se puede. Tendría como que
No,
agregarlas por aparte. Okay, welcome to subnetting. Before we start calculating subnets, the first thing we need to do is to take a look at what subnets and IP addresses are. An IP address is a numeric value that you configure on every device in a network. Think about computers, laptops, servers, but also networking equipment like routers, firewalls, and switches. The IP address identifies every device with a unique number. Devices within the subnet IP, within the same IP subnet, are able to communicate without using a router. Let's take a look at what some of the terminology you might encounter when we talk about IP addresses. Bits or bit. A bit has two possible values, 1 or 0, on or off. Byte, a byte is an 8 bits. Basically, a byte is composed of 8 bits. Octet, an octet is just like a byte, 8 bits. You often see byte or octet both being used. Nibble, a nibble is 4 bits. We'll talk about this more in the hexadecimal chapter. Network address. When we talk about routing, the network address is important. Routers use the network address to send IP packets to the right destination. 192 and 168, the 1.0 with the mask with subnet mask 255.255.255.0 is an example of a network address. Subnet is a network that you split up in multiple smaller subnets. Broadcast address. The broadcast address is being used by applications and computers to send information to all devices within a subnet. 192 and 168, the 1.255, with subnet mask 255.255.255.0 is an example of a broadcast address. Hierarchical IP addressing. IP addresses are 32 bits divided in 4 blocks, also known as 4 bytes or octets. Every byte has 8 bits. 4 by 8 equal 32 bits. There are many ways to write down an IP address. We have decimal, binary, and hexadecimal. Decimal is what we are used to work with, as this is the way you normally configure an IP address in operating systems like Microsoft Windows, Linux, or most networking equipment. Hexadecimal you won't see often, but for example, you might encounter this in the Windows registry. Okay. IP addresses are hierarchical. Okay, the important here is sometimes we use the hexadecimal for MAC addresses. If we take into consideration how many IP addresses can we have with hexadecimal, it will be 4.3 or 4.3 billion IP addresses. The advantage is actually 4,294 billion 9,067,296 IP addresses for IPv6. which is actually bigger or larger than IPv4. The advantage of having a hierarchical model is needed for routing. Imagine that every router on the planet would need to know every IP address on the planet. Routing won't be very efficient that way. A better solution for a hierarchical model where you use network, subnet, and host. Try to compare this to phone numbers. The first one, this is the country code for the Netherlands. The second, this is the city code for Tilburg. And the last one, this is a single number for a customer. To complete the phone number 0031 013 1 2 3 4 5 6 7. IP addresses use a similar hierarchical structure. Network addresses. Every subnet has one network address. The network addresses is a unique identification of the network. Every device within the same subnet shares this network address in its IP addresses. For example, 100.1, 100.2, 100.3. The 192 and 168.100 is the network address, and the .1, .2, .3 are the host addresses. The IP address will tell you in what subnet they are located. The network address has to be the same for all the hosts. The host part has to be unique. When the internet was invented, they created different classes of network. They created different classes of networks, which each with a different size. At this moment, there are three classes that are important for us, to us. Class A, we have 8 bits for network, and then we have 8 bits for host, 8 bits for host, 8 bits for host. Class B, we have the first 2 octets for network, and the second part of octets, those are for hosts, dedicated for hosts. And finally, we have class C, which actually is the first 3 octets are network, and the last octet is host. Class D is for multicast purposes only, and class E is for research. Okay. Broadcast addresses. Every subnet has one broadcast address. When we talk about broadcast in IP world, we talk about layer 3 broadcast. In case you have no idea what I am talking about, take a look at the OSI model. We are talking about layer 3, that will be the network layer. The OSI model describes a layer approach of a network, getting into the details of all the different layers of the OSI model. It's outside the scope of that book, but to get an understanding of broadcast, it's important to look at layer 2 and layer 3. There is a layer 2 and a layer 3 broadcast, and there is a big difference between them. When we look at a LAN, local area network, we are possibly using Ethernet. MAC addresses are used to uniquely identify a network device. For example, 00 colon 50 colon 56 colon 0 colon 00 colon 08 is a MAC address that uniquely identifies my computer. On a LAN, it's possible to send a layer 2 broadcast so that all computers on the LAN segment will receive this message. Ethernet frame. The destination MAC address would be FF, column FF, column FF, column FF, column FF, column FF. When you read the hexadecimal chapter, you'll see that FF, column FF, and so on. It's a string with only ones in binary. Now, let's take a look at a layer 3 broadcast. Layer 3 is where we talk about IP addressing. And we can also send a broadcast. For example, take a look at the address network 192 and 168, the one that's 0. The broadcast address for this will be 192 and 168, the one that 255. For this subnet, this is the broadcast address, meaning when we send an IP address to the 192, the 168, the one that 255, it will automatically send the notification or the message to all of the hosts in this subnet, and they will be receiving this package. Pretty neat, right? Some old applications might still use this form of communication. Class A. Back to our network addresses. Let's take a look at Class A. The first bit always has to be a 0. This leaves us 7 bits to play with. The lowest value you can create by changing all bits to 0 is 0. By changing all 7 bits to 1, you will get 127. In this case, we start working with the first one as 0 all the time. And if we combine them together, the highest values that we will get is 127 in decimal format. As you can see, Class A range is between 0 and 127. Class B. For Class B network, the first bit has to be 1. The second bit has to be a 0. So, the first one is 1, the second is 0. So, the highest number that we get here is 191. And the lowest value that we get is 128, meaning the ranges for Class B, as you can see, Class B networks start with 127, and the last network is 191, meaning the range goes from 128 to 191. And then we have Class C. For the Class C, the first bit has to be 1, the second bit has to be 1, and the third bit will be a 0, meaning the highest value that we will get is 223 with all of them in ones, and the lowest value 192. Okay, with that being said, the range goes from the IP address of 192 to the IP address of 123. That is basically what it means. As you can see, Class B networks, actually, he made a mistake because he was saying Class B, but we are with Class C. So probably he meant Class C. Class C networks is the one we're working on. We're talking about Class C networks goes from the 192 to the 223. So there is a small mistake there. We might have to correct it. I'm not able to write. Okay, so just be aware that the last one, Class B, is from 128 to 191, and Class C is from 192 to 223. Class D and E, there are also a Class D for multicast traffic, which start with 224 and it ends at 239. Class E is for research usage. We are not going to use these classes for our binary calculations. Okay. Everything clear? Oh, good. No questions? Okay, let's continue. Let's move on. Class A. A Class A network has 1 byte reserved for the network address, which means the other 3 bytes are left for hosts. Let me just close this one so we can concentrate in the book and the reading. So Class A. A Class A network has 1 byte reserved for the network address, which means the other 3 bytes are left for hosts. This means we have a couple of networks, and every network can have a lot of hosts. How to determine how many hosts each network has, we will see later. So in this one, we will have the first byte for network and the other bytes for host, host, and host. This is a Class A. If we look at the IP address 53.21.43.63, then 53 is the network address, and the 21.43.63 is the host address. Meaning all machines in this subnet will have the 53 as the network address. Okay, so this is the network address, and the rest are host addresses. Class B, addressing. A Class B network has 2 bytes reserved for the network address, which means the other 2 bytes are left for hosts. Meaning we have even more networks, but less hosts per network compared to Class A. The first 2 bytes are network. The second 2 bytes are, or the last 2 bytes, to be more clear, those are hosts. An example of a Class B, 172.16.100.68. The network address is 172.16, and the host address is 100.68. In this one, the network for all devices will be 172.16, and the host will be 168, and so on. So the last 2 octets are used for host, and the first 2 octets are used for network. And finally, we have Class C addressing. Class C has 3 bytes reserved for the network address, which means the other bytes are left for hosts. Now, we have a lot of networks, but only a few hosts per network. Network, hosts. Meaning the first 3 bytes are for network, and the last of them is reserved for host. Another example in this case will be 192.168.200.53. The network address is 192.168.200, and the host will be that 53, the host address. Meaning all of the network devices will start with 192.168.200, and so on. Okay, good. Are you still there? Yep. No. All right, John is gone, but let's move forward. Let's move forward with this. We have private IP addressing in this case. So let's focus on the important part here. We have to understand that the important of this is that the Class A for private IP addresses ranges goes from 10.0.0.0 to 10.255.255.255. Class B, they go from 172.16.0.0 to 172.31.255.255. Class C will be going from 182 and 168.0.0 to 192.168.255.255. Where are we going to apply these addresses? In private companies, in intranets mainly. So if we want to talk about case uses of real life, and when do we apply these IP addresses, is mainly when we have an intranet or when we are working with companies. Within the IP addresses of that specific company, we will have private IP addresses. If you are talking about your home computer, you will have a private assigned reserved address for your computer, basically. Subnetting the beginning. Let's talk about Class C network and take a look at it. We can play around with binary numbers. Okay, so in binary, 192 and 168.1.0 looks as follows. We have the first two bytes on, then we have the first one, the second one off, the first one on, and so on. So basically we have 3 bytes in this specific order that are on, and the rest of them in zeros. Then we have the only 1 byte that is turned on, and then we don't have any bytes turned on. So if we do the conversion of this, how are we going to know what does every number of this represent? We have a table that goes from 128, then we have 64, we have 32, we have 16, we have 8, 4, 2, and 1. And we have to memorize this table in order to do some netting, because every time we do a change from decimal to binary and from binary to decimal, for example, if we want to go and get this value of 168, we have to turn this bit. This one will be off, this one will be turned on, this one will be off, this one will be turned on, and all of them, the rest of them will be in zeros. If we add 128 plus 32 plus 8, we will get a value of 168, a total value of 168. And that's the way that we are able to do some subnetting. Let me improve the size of this. Maybe we can improve the size. Are we able to? I'm wondering. I'm trying to do. All right. Great. Now I got it. So it is important to memorize this table in order to do your subnetting and understand decimal format and binary as well. In the previous chapter, I explained and we studied a little bit about the Class C network. We have the first 3 bytes of network and the last byte of host. Now the question is, how does a network device know which part is the network part and which side is the host part? It's because it's Class C network. It's a Class C network. It is. Is it some secret rule that everyone just knows about? The answer is no. We use something called the subnet mask. For this network, it would be the following subnet mask: 255.255.255.0. Now, what does this subnet mask exactly do? The word mask might tell you that it must mean that it's hiding something, but that is not the case. And to show you the answer, we will have to look at some binary numbers. Here we have the subnet mask in binary, and we have the conversion of the decimal 192 and 168 1.0 to binary format. Okay, now take a look at this. All the numbers ones that are turned on for this specific mask are in red color at this moment, meaning we are using them to finally discover where this network belongs to. And we will see more about this later on in this explanation. How are we going to understand this? Well, basically, let's follow step by step and understand the process. So let's write down those host bits. We have the first one is 255. Well, all numbers are in ones, meaning all bits are turned on. The second one, we have another explanation we are going to go through in a few seconds. Okay, so let me see. Okay. Yes, I want to continue in the call. Cool. So now we know that with 8 bits, the highest value we can create is 255. Does this mean we can have 255 hosts in this network? The answer is no, because for every network, there are 2 answers we can't use. Network address. This is the address where all of the host bits are set to 0. This is the first octet. The broadcast address. This is the address where all of the host bits are set to 1. This is the broadcast address. So the first one is the network address. The second one is the broadcast address. All right. So let's take a look at this. So let's take 255 minus 2 is 253. Does this mean we can have a maximum of 253 hosts in our network? The answer is still no. So I mess with your head because the highest value you can create with 8 bits is not 255 but 256. Why? Because you can also use the value of 0. So in this case, does this make your head spin? Let's take a look at our 192 and 168.1.0 network in binary. So we have the IP address. We have the binary conversion. We have the subnet mask and the binary conversion. We have the network address. We have the conversion to binary. And we have the broadcast address and we have the conversion to binary. That's basically what we have so far until this moment. The network address has all hosts set to 0. So in decimal, this is 0. The broadcast address has all bits set to 1. So in decimal, this is 255. This means everything in between we can use for host 1 minus 254, or basically this is a range 1 through 254. So that's 254 valid IP addresses we can use to configure host. Don't start consuming at 1, but start counting at 0. The 0 is a valid number. Great. So now that you have seen what a network looks like in binary, what the subnet mask does, what the network broadcast address are, and that we can fit in 254 hosts in this class network. Now, let's say I don't want to have a single network where I can fit in 254 hosts, but I want to have 2 networks. Is this possible? It sure is. Basically, what we are doing is taking a Class C network and chop it in 2 pieces. And this is what we call subnetting. Let's take a look at it in binary. We have the IP address in decimal, the conversion, the subnet mask, and the conversion. If we want to create more subnets, we need to borrow bits from the host part. For every bit you borrow, you can double the number of subnets. By borrowing 1 bit, we can create 2 subnets out of this single network. There are 8 host bits, so if we still want to create 1 more subnet, this means we have only 7 bits left for this host. Let's look at the conversion. We are borrowing 1 at this moment, and we are using the subnet mask for this conversion. Take a look at this. We are borrowing 1 right there. It is in red color. The first 24 bits are the same, so we only have the 4 octet. Let's write down those bits. Take a look at the red one. There is the bit that we are borrowing at this specific moment. To calculate the decimal, and you'll have 128, the subnet mask will be now 255.255.255.128. The second question is, how big are these subnets? And how many hosts can we fit in? We'll take a look in a moment. We have 7 bits left, so let's do the binary to decimal calculation. 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 127. Don't forget about the 0, because we can use the 0. The highest value we can create with 7 bits is 128. Our original Class C network has now been divided into networks with a size of 128 each. So what will the network address of the two network subnets be? Let's work this example out in binary. Subnet number 1, by applying the new subnet, we only have 7 host bits to play with. 192 and 168.1.0, 255.255.255.128. Let's take a look about which subnet are we going to finally get here. Okay, we do the conversion decimal to binary for both the IP address and the subnet mask. Now, the network address for all host bits set to 0, it will be 192 and 168.1.0. Okay, we have talked about this before. The first usable address will be 192 and 168.1.1 in this specific example. And what is the last usable address? In this case, the last usable address we can use for this host is the one before the broadcast address. So this will be 192.168.1.126, meaning the broadcast will be 1.127. The broadcast address has all bits set to 1. So the broadcast address we can get is 192 and 168.1.127. Remember, we're not using this bit because we're playing with it to create new networks. So if we add up together the rest of the bits, it will give us the broadcast address of 192 and 168, the 127 minus 1, we get the last usable IP address. Now, how are we going to know the next subnet if we want a second subnet? Remember, the last one was 128. And if we add 1, we are going to get the first subnet for the second subnet. It will be 192 and 168.1.128. That will be the first one. We are repeating the process of using the broadcast, the subnet mask that we have before, 255.255.255.128. Now, let's do the following. Let's follow up. We got the first one. Now, how are we going to know what is the first one? Because this is the network. This is the network address, 128. After that, we add 1, a number 1, and we get the first usable IP address for computers or hosts. In this case, will be 192 and 168.1.129. Okay, we got that correct. Now what? Now we have to figure out the broadcast address with all zeros. It will be 192 and 168.1.255 minus 1. We get the last usable IP address, which is 192 and 168.1.254. The last IP address we can use for this host is the one before the broadcast address. So this is 192 and 168.1.254. That is the last IP address. That's basically what we want. That's it. That's the first network we just subnetted in 2 subnets. And we found out what the network and broadcast address are and what IP addresses we can use for hosts. Let me show you another one. We can take the same 192 and 168.1.0 network, but now we want 4 subnets. For every host bit we borrow, we can double the number of subnets we can create. So by borrowing 2 host bits, we can create 4 subnets. Now, we are borrowing 2 host bits, meaning the subnet mask will be 192.255.255.192. That's what we are going to use to create these subnets. The first one, we have it there, 192 and 168.1.0, and the subnet is the 1.192. Now, let's take a look at the magic, because the network is the 192 and 168.1.0. That is the first network. The first usable IP address is 192 and 168.1.1. And if we add all of them in once, we are going to get the value of 63 right there. Minus 1, we get the 62. meaning the last usable address will be 192.168.1.62, and the range will go from the 1.1 to the 1.62. That is the first range of usable IP addresses. Okay, next one. We continue adding. After the 63, we get the 164. The 1.64 will be the network address. We add 1 to that, and we will get the first usable address, 192.168.1.65. Now, remember that we were working with all zeros there, except that in this time, we are not using the first one or the last one, only the rest of them to all ones. To get the last IP addresses available for this one, 192.168.1.126. Now, if we add all of them in ones, except the first one, because we are borrowing these two, if we add all of them, we get the value of 127. If we change all those zeros to ones, we get the value of 127. And that is the specific broadcast address that we have. Now, what is the range for this? They will go from the 1.65 to the 1.26. Okay, we got it. We got the first network and the second network. Let's look at the third one. And in this case, is the same subnet mask, starting from the last usable host address that we have here, the broadcast. After that, we add 1, and 182 and 168, the one that 128 will be the next network. We got the network. Now what? Now we have to do the following. We have to add all of them in zeros to know the broadcast. In this case, it will be a little bit different because we are not using some of them. We're using most of them, but not all of them. We are only adding all of them to get a value of 191. That is the broadcast address. We subtract 1 and we get the last usable address, which in this case is 192 and 168, the 1.190. Meaning that if we add all of these numbers together and this number 1 there, we get a value of 191. Now, if we do the same, but instead of this one, we have a 0 there, we get the last usable address, which is 190. This third network goes from the 192 and 168, the 1.29 for the first IP address available for hosts and computers, to the last 192 and 168, the 1.190 for the computers and hosts. Those are the only valid IP addresses that we can use to assign to devices. And we have to go for the next one. How are we going to do it? Same process. We use the subnet mask. In this case, is the 255, the 255, the 255, the 192. And we are borrowing 2 bits. Now, the last IP address one was 192 and 168, the one that it was 190. So if we add 1, we get the broadcast. If we're adding 1 more, we get the first usable address for the fourth network, which is 192 and 168, the 1.192. That is basically the for subnet, the last network that we will be working on. Now, let's take a look at what happened when we add convert all numbers in the binary to ones. We get a value of 254. 255 actually. 255 will be the broadcast address. Meaning, if we subtract 1, we get the last usable IP address. And in this case, this is what happened. The range will go from the 192 and 168, the 1.193, because this is the network. It's not usable yet. 193 will be the first usable address. It will go from 193, 1 to 191, 192, 168, the 1.193 to 192 and 168, the 1.254. Those are the addresses that we can assign to computers and host devices. Now, it's a little bit difficult to understand at first because you have to be very precise regarding converting to decimal and binary to decimal. But with practice and more practice, you will understand this fully and it will be easier for you. There is another method that we will look into later on in this course. Is called the magic number, and you can do your own research and investigate how to do it. We are going to leave it like this for now. This is the first step in subnetting and creating your networks. We have done a couple of examples which have been great and amazing. Let me see until which page are we covering today, because we're ending the class for now. Okay, so we are able to cover at this moment until page 22. We were able to cover until page 22. And let's see which one was the first one where we start this. Let me go back. The subnet, the beginning. So we start at page 14 and we finish today's lesson at page 22. It's about eight different pages, or actually 24. Maybe I was mistaken. Yeah, 22 of this one, but in this case it's 23. It's 23. So we're done with the class. This is the first class in subnetting. I hope you have an amazing week, an amazing day. Please practice, because practice makes perfect. I see you around. Take care, boys and girls. Goodbye.